Solve the following rational inequality. Write your final answer in interval notation. So 2x minus 3 over x squared minus 1 is greater than or equal to 0. Okay, these are solved very similarly to polynomial inequalities, but we have to consider places where the numerator is 0 and the denominator is 0 as places where the function can change from positive to negative. So zeros of the numerator, if I take 2x minus 3 and set that to 0, I would get 2x equals 3 or x equals 3 halves. Zeros of the denominator, if I take this and set it equal to 0, I get x squared equals 1, so x is plus or minus 1. So that tells me, let's see, I put negative 1 first, then positive 1, and then 3 halves. All right, so that tells me I've got 3 intervals to test. This is looking for values that are greater than or equal to 0, so I'm looking for things that are positive, but also potentially equal to 0. But the thing is, negative 1 and positive 1 result in division by 0, so I can't include those no matter what. But I could potentially include 3 halves as part of my interval, so I can go ahead and mark that if I like. But to figure out what's happening within these intervals, I need to get test values. It's like negative 2, 0, between 1 and 3 halves. Let's see, that's 1 and 1.5. So how about 1.1? That'll be fine. And then 2. All right, so if I plug each of these values into my function, let's see what comes out. All right, so if I put negative 2 in, negative 2 times 2 gives me negative 4 minus 3. Doesn't really matter what that value is, it's a negative number, okay? And then if I put negative 2 in and square it, that's going to be 4. 4 minus 1 is 3. That's a positive value. So a negative over a positive results in a negative. Now if I put in 0, this would be 0 minus 3, so that's a negative value, negative 3. And then 0 minus 1, that's also negative. So negative divided by negative gives me a positive. 1.1, let's see what happens there. This would be 2.2 minus 3, so that's still a negative. 1.1 squared, that should be slightly larger than 1 if I'm remembering correctly. Let's check it on the calculator here. Yeah, 1.21. So 1.21 minus 1, it doesn't matter what it is, it's just that it's positive. So the result here is negative values. And then if I plug in 2, this will be 4 minus 3, which is positive 1. 4 minus 1, which is 3, so that's positive as well. And 2 positives divided gives me a positive. Okay, so the intervals that are positive would be this one and this one as well. So my final solution here would be the result, or the interval from negative 1 to 1, both exclusive, and then union, 3 halves inclusive to positive infinity.